So the format last time worked pretty well. We did 2 parts. We did like current events, like recent discoveries, and then we did education. So we have our thinking caps on tonight, definitely. The pie. As I solicited like ideas for what to talk about, like what's really amazing, what's really impressive, what do you love? And my friend said pie, and I was like, all right, we'll do it. Ready to go? Current events. There's 2. The European Southern Observatory announced the discovery of the first asteroid in the ring system. We didn't know asteroids could do this. But not to be outdone, NASA, about an hour later, had an announcement of their own of a new dwarf planet that was discovered well beyond the orbit of Pluto. Okay, so orbits have to make mathematical sense based on their shape and gravitational interactions with other bodies. The orbit of this guy does not. So the best proposal that we have so far to make sense of this thing is the existence, right, of another planet larger than Earth that orbits even farther from the sun, waiting to be discovered. I'm excited. Number 2. Data from the Cassini mission at Saturn shows a blob at the edge of one of the rings, where it appears that the ring material is sort of collecting together in a clump. That clump is about to experience a gravitational tug from one of the moons, and we expect it to be pulled out of the rings and placed into orbit around the planet. What this means is that we're watching live the birth of a new moon. This is like 2 weeks old. It's fantastic. Wow. Fun fact, the guy who discovered it, it was his mother-in-law's birthday, and he forgot. That is why the moon is named Peggy. True story. Okay, weapon of choice. My first thought with weapon of choice was the thermonuclear bomb, but I enjoy dramatics, and that's not big enough. So I went with something a billion times more energetic, and I asked Mr. Owens and his ukulele to help me set the mood tonight.
All right.
The sun is so hot that everything on it is a gas. Aluminum, copper, iron, and many others. If the sun were hollow, more than 1 million Earths would fit inside, but it is only a middle-sized star. The sun is far away, about 93 million miles away, and that's why it looks so small. Even when it's outside, the sun just right on it. The sun is a massive incandescent gas, a gigantic nuclear furnace, where hydrogen is built into helium at a temperature of millions of degrees. So with the sun as inspiration, I want to share the most overwhelmingly awesome thing that I know. Richard Feynman says to teach the wonders and then explain them. So we're going to begin with an idea that everybody here has heard before but may not kind of know the background. Then we're going to explore that. Quoting Carl Sagan, "We are made of star stuff." Yeah, that's not tattooed here. So atoms are what everything in the universe is made of. The Earth and life on it, and you and me. Atoms, all of it. Even the pie that's out in the lobby, which if you haven't had already, please get it and take it home. So here's the amazing thing. We understand where those atoms came from, and we can trace their origins to the stars. The Big Bang Theory describes that the early material universe consisted only of the lightest elements. Hydrogen, helium, and trace amounts of lithium and beryllium. Those are numbers 3 and 4 on the periodic table. Everything else has to be made. So in what's called the B²FH paper is landmark research. It's titled the synthesis of the elements in stars. Yeah, published in 1957, and it analyzes several processes by which those light elements are cooked into heavy ones under conditions of extreme temperature and extreme pressure at the core of stars.
The sun is a mass. We are furnace. We're hiding in the built in the
What he said. So in its later years, our sun will also support other processes to make even heavier elements than helium. The easiest one to explain and the most common among them is called the S process. And we're going to talk about this. So what happens is a neutron flying around the core of the sun collides with the nucleus of an atom and it sticks. So the nucleus is bigger and sometimes it decays into a proton and then you get a new element. You can build all the way up to number 26 on the periodic table, 26 protons of iron.
And yet,
in the core of the sun
is only a middle-sized star.
So there exist stars that are 100 times the mass of our sun, and those synthesize heavy elements in the exact same way. But these high-mass stars, they have a different trick. They turn into a supernova at the end of their lives. They collapse and explode at super high energies, at super high temperatures, and it's under these extreme conditions that every other element is formed. This explosion causes them to spew out their chemically enriched guts across the galaxy. These guts form into the next generation of suns and planets. This paper describes processes that not only account for the creation of every element in every isotope form known in nature, and this is where my mind starts to get a little blown, it also predicts the abundance of each isotope. There's more hydrogen than helium in the universe, there's more oxygen than carbon, more iron than sulfur, and so on and so forth. When we look out into the Milky Way galaxy with the spectroscope, we observe elements in these predicted proportions. These guys figured out how nearly everything we know came to be, and that's why I think that their work is humanity's greatest achievement. So stars had to form and die to create the carbon and oxygen in the Tennessee limestone below your feet, the gold in your jewelry, the silicon in your smartphone, the iron in your blood, and the calcium in your teeth. We're in the universe, but the universe is also in us. We are made of star stuff. I want to close the same way I began, with a quote from Carl Sagan. He says, "If you wish to make an apple pie from scratch, you must first invent the universe." Thank you.